Afternoon and welcome to dividing functions. We're going to talk about division, which is the inverse operation of multiplication, and that it undoes multiplication. All right? So, for instance, if I do a times 1 over a, the a's cancel and I get just 1. All right. We're going to talk about dividing functions using tables. We can use a table of values. Consider f of x and g of x. These are the two functions, all right? So we can create a table of values for each of these, yes? So if f of x is 3x minus 5, if I plug in 0, it's minus 5. If I plug in 1, 3 minus 5 is minus 2. If I plug in 2, 3 times 2 is 6 minus 5 gives me 1, and then 4, and then 7. For 3x squared times 2x minus 5, we plug in the x into both spots, right? So if it's 0 both times, then I'm going to get minus 5. If I plug in 1, it's 3 times 1 squared minus 2 times 1 minus 5, which is 3 minus 2, 1 minus 5, so that's negative 4. And if I plug in 2, 3 times 2 squared minus 2 times 2 minus 5, that is 3 times 4, so this is 12 minus 4, so 8 minus 5, which is 3. And 3 times 3 squared minus 2 times 3 minus 5. This is going to be 3 times 9, so 27 minus 6, so 21 minus 5, which is 16. And then 3 times 4 squared minus 2 times 4 minus 5. This is 3 times 16, which is 48. 48 minus 8 is 40. 40 minus 5 is 35. Okay, awesome. Now, we can figure out what h of x is by doing f divided by g. So I'm going to do minus 5 for f divided by minus 5 for g. That's 1. Here I'm going to do minus 2 divided by minus 4. That's 1 half. And then I do 1 over 3, which is 1 third. And then I do 4 over 16, which is 1 over 4. And then I'm going to do 7 over 35, which is 1 over 5. Okay, so what has happened here? Finite differences and successive ratios. See if we can determine what type of function f of x is. All right. I can see that I've got f divided by g. Yeah. So what I've got is this is, if I use finite differences, right, that means I'm looking at the difference of each of these, how much it goes down. This is minus 1 half. This is from 1 half to 1 third. That's minus 1 over 6. From 1 third to 1 12th, that's minus 1 over 12. From 1 fourth to 1 fifth, that's minus 1 over 20. Okay, that's not very helpful. So yeah, I don't think either of these are going to work, right? Because what I've got is I'm doing f divided by g, yeah. Because this is just getting to a smaller and smaller fraction, right? Getting these common denominators is very complicated. So h of x is likely, but not definitely, a new / different type of function. Okay, so aka IDK. But that's how we would divide those two functions, all right? Now let's do it the other way around. Now we're going to do g divided by f. So same functions, right? This is g and f, same function, so let's put these same numbers in. I've got minus 5, minus 2, 1, 4, 7. And then for my g, I've got minus 5, minus 4, minus 5, minus 4, 3, 16, 35. Okay, same numbers. Now we're going to do g divided by f. So again, this is minus 5 over minus 5, which is 1. But the next one is minus 4 divided by minus 2. That is 2. And then I've got 3 divided by 1, which is 3. And now I've got 16 divided by 4, which is 4. And now I've got 35 divided by 7, which is 1. Okay? Finite differences, this one should jump right out at you each time I go up 1. I've got my finite difference is 1, and it's linear. All right? Can we determine algebraically the function rules for h of x and j of x? All right? Okay. So can we determine algebraically? Yes, we can. All right? And the way that we're going to do that, check this out. We are going to, we're going to factor g of x. All right? G of x equals 3x squared minus 2x minus 5. All right? So can this factor? Well, our a times c, 3 times 5 equals 15. So what are the factors of 15 whose difference is 2? Well, guess what? It's 3 and 5. So I'm going to need the larger one to be minus, so this is going to be 3x squared minus 5x plus 3x minus 5. All right, let's see, I can factor out an x out of this one. So this is 3x minus 5. And then I can factor out a plus 1 out of this one, and it's still 3x minus 5. So this factors as x plus 1, 3x minus 5. All right, so let's determine algebraically the function rule for h of x. All right, h is f of x divided by g of x. All right, h of x equals f of x divided by g of x. All right, so f of x was this one. It's 3x minus 5. And g of x, and I'm going to use the factored form of g of x because it's x plus 1 and 3x minus 5. All right, what do I notice? I notice that I can cancel the stuff in the numerator and the denominator, and I get 1 over x plus 1 for h of x. Okay, for my j of x, this is g of x divided by h of x. So it's just the inverse of this. It's x plus 1, 3x minus 5 over, and sorry, this is, you guys, this is g divided by f over 3x minus 5. All right, and again, that cancels, so this is x plus 1. Okay, so here we go. F of x is a linear function, isn't it? F of x is linear. And g of x is quadratic. So if I think of just the leading term, and I do f of x over g of x, f of x is linear, so that's like an x something. G of x is x squared. This becomes a 1 over x, which is an inverse function. That's what we call an inverse function. It is a function that is linear in the denominator, okay? And this one is going to be x squared something over x, which gives me x, so this one is going to be linear. Okay? So if I've got a linear divided by quadratic, I get something that has just x in the denominator. If I do quadratic divided by linear, I come up with a linear. All right? Let's practice with another pair of functions. Okay, here we go. We've got f of x and g of x. This time f of x is quadratic. So if I plug in 0, I know I'm going to get minus 3. If I plug in 1, I've got 4 times 1 squared minus 4 times 1 minus 3. Those two, this is 4 and this is 4, so that is still minus 3. If I plug in 2, 4 times 2 squared minus 4 times 2 minus 3. This is going to be 4 times 4, so 16 minus 8. 8 minus 3 is 5. Now I have 4 times 3 squared minus 4 times 3 minus 3. This is going to be 9, so 4 times 9 is 36. 36 minus 12 is 24. 24 minus 3 is 21. And lastly, I've got 4 times 4 squared minus 4 times 4 minus 3. This one's going to be 4 times 16. This is 64 minus 16, which is 48. 48 minus 3 is 45. 2x minus 3, a lot easier to do. Starts out at minus 3. It's going to go up by 2 each time, so minus 1, 1, 3, 5. And now let's do f divided by g. So I'm going to do minus 3 divided by minus 3, which is 1. I'm going to do minus 3 divided by minus 1, which is 3. I'm going to do 5 divided by 1, which is 5. I'm going to do 21 divided by 3, which is 7. And I'm going to do 45 divided by 5, which is 9. Okay? What is the function rule for h of x? Well, we know we can look at this, we got this point 0, 1. All right, so our y-intercept, where x equals 0, is 0, 1. And then it goes up by 2 each time. So this is h of x equals 2x plus 1. So plug in 1, 2 times 1 is 2, plus 1 is 3, 2 times 2 is 4, plus, yeah, so that's how it works. Okay? So I can do that. I can do that just by looking at the table and doing regression, or doing what I know about finite differences. Okay? All right, last little bit here. Let's evaluate these algebraically. We're always going to factor out the trinomial. Okay, so here I got 2 times 5 is 10. The factors of 10 whose difference is 9, that's going to be 10 and 1. All right, so this is going to be 2x squared minus 10x plus x minus 5. So I can factor out a 2x times x minus 5 and a plus 1 times x minus 5. So this one becomes 2x plus 1 over 2x plus 1 and x minus 5. The 2x plus 1s cancel. I leave 1 behind. So this is 1 over x minus 5. X in the denominator leaves it as an inverse function. All right, I've got 2x squared minus x minus 10. So 2 times 10 is 20. I need the factors of 20 that have a difference of 1. So it's 4 and 5. So 2x squared, and minus is my bigger one, minus 5x, plus 4x minus 10. So I can factor out an x of this one, 2x minus 5, and a 2 out of this one, 2x minus 5. So this is x plus 2, 2x minus 5. You may notice that something always cancels. This is algebraic reasoning. So we're going to make it easy on you. Something should always cancel. Over x plus 2, that cancels, and I get 2x minus 5, which is linear. Don't be afraid to pause it here and work out this one for yourself. All right, notice that I have a GCF of x right off the bat, so I can factor out x times 6x squared minus 7x minus 20. So now I need 6 times 20, which is 120. I need the factors of 120 that have a difference of 7. Well, let's see what they are. 1 and 120, no. 2 and 60, no. 3 and 40, obviously no. 4 and 30, no. How about 6 times 20? No, that's no good. 7, 8. I can do 8 times 15. There they are. That has a difference of 7. So this is going to be 6x squared minus 15x plus 8x minus 20. I'm factoring this guy that's inside the parentheses. So let's see, I can get a 3x out of this, 2x minus 5, and a 2 out of this. Nope, not a 2, a 4. I can get a 4 out. 4 times 2x minus 5. So 3x plus 4 and 2x minus 5. Again, something factors. And recall, we should check every time. 3 times 2 is 6. 4 times 5 is 20. I've got plus 8 minus 15. That gives me minus 7. So this one is actually equal to x times 3x plus 4 times 2x minus 5, all over 2x minus 5. So the 2x minus 5's cancel. This becomes x times 3x plus 4, which is 3x squared plus 4x. This is a quadratic. And I have this one was a cubic divided by linear. So this was x cubed something over x. That gives me x squared for quadratic. Okay, hope you enjoyed our notes. And if you have any questions, talk to me the next time you see me. Thanks and have a great day.